Welcome everybody to Learning With Lowell. I'm your host Lowell, serial entrepreneur, problem solver, and startup advisor, and your host for the show. Obviously, every week we talk to scientists, artists, teachers, startup founders, and today we're joined with Kirill Korotaev. I'm so sorry on the last name. I looked up how to say your first name, but the last name I could not find. There was no translate how to say. Can you say it? I'm sorry.
Korotaev.
Korotaev? Oh, that's a cool name. Co-founder and CEO of Purple Gaze, an AI platform for collecting data from the brain using eye movements. He is based in Utrecht, and I'm not allowed to say this, you'll not hear this part, and which is the first person to be in that area that was going to be on the show. Just remember to subscribe, like, and all that type of stuff. It tells the Google guys that this is stuff worth seeing. Kirill, thanks for being on the show. Thanks for coming on.
Thanks for inviting me.
Yes. And is your just as a quick thing on your last name, does it mean anything? Is it got a cool history like Tolstoy or something? Tolstoy has some actual interesting meanings to it. I'm reading War and Peace. That's the only reason why I ask.
No. I mean, yeah, I don't know the history of it, but the root is from Slavic, something to do shortening or something.
So you're a short shortening. So like Smith means I used to work with tools and stuff, but shortening's the only thing I can think about with shortening is deleting things and the bread. I don't know what else shortening. Thompson, for instance, is son of Tom. So somewhere in my past there was a guy named Tom who's you're my son. So I'm gonna call you Thompson. The Norse names are quite boring. But Korotaev, I don't know. I always wonder if there's some cool history in the names.
Yeah, probably it is, but unfortunately I'm not aware of it.
Yeah, no worries. So for Purple Gaze, can you describe in layman terms what is it about and how it works to track eye movement and collect data from the brain? I assume it's a simile that somehow. Well, I won't guess. How does it work in layman's terms?
Yeah, so the eyes are an observable extension of the brain, and by precisely following where the person is looking, for example, on the computer screen, we can reverse engineer what's happening in the brain and obtain deep insights into human cognition. So we have built our Foxy eye movement based platform that can track eye movements data at 600 hertz sampling frequency. So we have this camera-based system. So basically, it is a USB device. So it's connected to the computer screen, and the participants see some stimuli videos or images or websites or anything, and during that our Foxy system monitors their eye movements in real time, and then it outputs the gaze coordinates XY as compared to where the person was looking and what was playing at this moment on the screen.
Do you track the Z coordinate? I don't know, depending on your Cartesian, but where it gets closer and further away depending on where the eye is looking, or is it just the main Cartesian system?
Yeah, on the X and Y.
Yeah. Okay. Yeah. So there's no Z where it comes nearer or further in terms of eye tracking.
Depending on the, so yeah, it's always application specific. So so we do our current system is screen based system. So I think it doesn't make a lot of sense to have a gaze coordinate for the Z dimension. But if you're doing in natural environments with eye tracking glasses, for example, then it may make more sense to do that.
Yeah, it makes sense. If you're just looking at a computer screen, there's really everyone has a standard Z in terms of how far away they are, ideally, unless There's some people who are like an inch away and then burn their retinas out. So you have the physical system that you just showed us for people who are just listening in. It's kind of like a medical device with some buttons and a really cool looking camera. How is that component developed? Did you use 3D printing? Is that a prototype? Like how, just in terms of the physical device, which from startups that I've been on who are, when they do more, hardware tech, it's much more laborious to do that type of thing. So I'm curious, how was that designed? How did you do that?
Yeah, first a little disclaimer, it's not yet a medical device. So currently it's used for research purposes in neuroscience, experimental psychology, and vision. So then how we get around to building this stuff. So actually, our very first prototype wasn't a 3D printed enclosure. So, but then we figured out that the internals could get pretty hot when they are like performing at the maximum capacity. And so then we decided to move to the like aluminum cutting. So it's the enclosure is made of aluminum, which is kind of a natural heatsink.
Yeah.
So yeah.
And so it's just a normal CNC then machine to mill it, and then you put the electronics in there and the lenses to do the recording, and then it digitally probably goes to like the cloud. So from USB powering it to the device itself being machined and built together, then like a cloud component to make sense of the data. That's roughly the pipeline of how it's used.
No. So
okay.
Unlike most other tracking systems that are kind of just like camera plus infrared illuminators and like USB cable, ours is actually a computational device. So maybe you've noticed that the footprint is a bit larger than eye trackers that you may seen or used for like marketing or like UX research, for example. So the reason for that is that it's actually a computer. So we have our eye tracking system on chip running inside the device, and our core algorithms are deployed on that system on chip.
Oh, that's cool. So that's interesting. I was thinking it was just, like you were saying, the way other people do it is that it's like a camera and you're just like linking up to the cloud somewhere that is doing the computation for you, but it's all on chip. It's all on, I don't know if like premises is the same concept. I know servers, if it's on-prem, you just have servers nearby, but like, I don't know, on chip,
embedded system is, I think, the right terminology here.
Embedded system? Yeah, okay. And then are there any trade-offs in doing an embedded system versus something that just connects to, I think Tesla has an embedded system too, but I think they also have a cloud, or they're just using servers to do the research of the machine learning and AI, which then goes into the embedded systems. I'm not entirely sure how traditional AI and machine learning gets applied in these ways in embedded systems.
Yeah, that's exactly how we do it. So there is a trade-off, of course. So the upside is that there is no latency. Basically, like if you talk about like high-end eye tracking systems for like research grade ones that are like costs from 30,000 US and are like bulky machines that use like multiple computers. They use like one computer for the processing of the data and another one for like showing the experiment to the participant. So basically, we don't need a second computer because our device is a computer itself. But there is a trade-off. You're right. So because we can't put like super we can put a lot of computational power inside this aluminum box. I mean, we probably could do that, but we also wanted to be accessible for the most research cases. So that's why we have limited compute resources. So in terms of like machine learning algorithms, how you described it with Tesla is very accurate. So you use like so you can use like cloud or like on-prem GPUs for training models, and then you basically deploy them on the trained models on the embedded system.
Okay, that makes a lot of sense. Then, what are there standards? Are there standards of output or ability to read that you need to meet to be a good enough medical device that people want to use? Are there standards that when you talk to the researchers, when you talk to people doing that type of stuff, that they let you know like what level of data collection and the fidelity of data that they're looking for, so that you can then build accordingly? And if so, then like what are the levels that people look for?
Yeah, great question. So the choice of like eye tracking system would be always application specific. So if we are talking about applications that so if you take, for example, like marketing or something, like if the data is lower quality and there is like some measurement error, this likely or there is like several pixels difference or visual degrees. It won't actually cause some kind of disaster, or probably no one would ever notice that, and they'll be fine. But when we talk about like either neuroscience research or even medical applications, of course, there is a higher penalty for the measurement error, and so the accuracy becomes more important. So the two most important parameters for like these more demanding applications are sampling frequency. So basically, so basically, like kind of sampling frequency is like it establishes the depth of the data that you can extract from the system. So if you're like tracking eye movements at like 30, 60, like hundreds frames per second, in that case, your output would be limited to fixation data. So where basically fixations are like type of eye movements when we are looking at a particular object. So, and when we're looking at the particular object in space, we're so for example, like I'm looking at this bottle right now. So we tend to focus on this object with our fovea, which is an area at the center of the retina, which has a highest density of photoreceptors and therefore highest spatial resolution. And so these fixations are important if you only like want to understand where the person was looking. But if you want to like get insights into the brain. In that case, that wouldn't provide you much of an insight. So the other type of eye movements happens when we move our attention from like one point of interest. So, for example, I was looking at the bottle, and now I'm looking at the keyboard.
Mm-hmm.
So when I make this shift from one object to another, I make a rapid eye movements, and this rapid eye movements are called saccades. So why this is important? So, for example, we have blind spots in each of our eyes, but the picture of the world that we see is always complete. Mm-hmm. There are no gaps in our vision. So how is it possible? So it's because we are always making these rapid saccadic eye movements, and we are not like seeing the world as it is. Instead, we are actively constructing the representation of the world around us.
Yeah, it's if anyone's ever seen a pigeon as they're walking, now this may be like a dumb version of thinking about this. If you've ever seen a pigeon when it's walking, it like moves its head like all the time. Or if it's walking straight, it'll kind of like, if you watch its head, the head just kind of like the body moves, but the head kind of jumps. And so it's kind of like the way I think about it, it's like they're taking pictures and overlapping them to kind of get a sense of what's around them. It's not, you're not getting like a they don't see everything 100% of the time. They're doing all these different physiological things to get a sense of their environment so they don't get eaten by stuff. But for us, because we're hunters, like our stuff is very much geared towards like tracking and knowing things that are around us. But I always, if you ever just watch a pigeon or a bird move around, you'll see, especially pigeons. I saw this guy who was trying to shoot a pigeon, and I'm sorry everybody who's trying to shoot a pigeon, but he was aiming for the head, and the pigeon was doing the thing, and it would see the bullet coming and dodge. But if you aim for the body, it would not be able to dodge. But like, because the head is just always kind of moving to get a sense of their spatial orientation, for those blind spots. Because imagine having two ability to see on the side of your head, like you're missing a lot of your world if you're just sitting straight. It's kind of the same thing with humans. So basically, it sounds like in this case the saccades are a way of doing a similar thing, all without moving our head, but moving the eyes to get around that blind spot.
Yeah, we're so it's because that we evolved as predators.
Mm-hmm.
So like that's why we need like faster reaction, and kind of it's can be traced back to the hunters, I believe.
I think we're also really great at throwing rocks. Apparently that's like a species thing that we can do. Like any other species that has some level of projectile or tosses things, we're actually really good at figuring out where things are going and then throwing a rock to like hit that thing as it's moving around the environment, which is kind of like other animals really can't do that, which is interesting. Like they can run at something and bite it as it's moving. They'll like be able to see you're going this way 30 miles an hour, so they're gonna like meet you off at the pass, versus like sometimes people like would think run where it was versus where the hockey puck is going. There's a lot of humans are kind of weird. Animals are kind of interesting, but I think I was reading that like we're one of the few species that actually can like throw a rock or throw something and actually hit where we want it to hit uniformly. Yeah. Like
I didn't know that, but I think like the prediction of an object in the space is also non-trivial task for us humans, unless we're like particularly trained in it. For example, like if you're like playing tennis or table tennis, like when if you try to like hit the ball when it's like already landed nearby you, it would be already too late. So you kind of need to predict where it would land the next moment from when you originally looked at it.
Yeah.
And unless we're like we get better and better in it if we practice more and more. But we're not. It's not an inborn like ability. But I guess to some extent, our inborn ability is better than those of the other animal kingdom.
I think of it like the Petruvian man in terms of like what are the average abilities that people can roughly get if they put any amount of effort into it. And so like I think there's another species other than like sentience and math and stuff. I think if you just physically, one of our other abilities is like we don't really tire out. So like there's actually competitions where people will just like walk a deer down to like capture a deer or a horse and stuff. Like eventually an animal will tire where like humans can just keep going. Now if you say that nowadays, if anyone listening, you're like, can you imagine walking 20 miles straight to like catch a deer? You're like, well, I don't know if I could do a mile. Or a couple miles, like so, but like the average, like the capacity of our species is like that most people could reach that if they worked at it. So it's kind of like what you're saying as well. There are people that are like the Serena Williams that are just like lightning at knowing where everything is, but like the average person could probably like hit it back and forth with a little bit of work, which would then be better than any other species. But in terms of I'm sure we have other physical things that are neat, but in terms of the physical thing that you're making, so you have all the way down from the UI UX in terms of simplicity of what you need to be doing versus the complex, understanding what the brain's up to, and that's all on one device. Like it feels like the complex thing would be much more expensive to build versus the UI UX thing. Is it all one device, or is it like a series of devices that achieves each use case?
Yeah, there are different layers. So we have like a platform solution. So like at the at the most downward layer, we have like a hardware, which is an enabler for the algorithms to work at the capacity that we need. So then we have like core algorithms that just that are responsible for high speed and high precision eye tracking. And then on top of that layer, we have applications.
Okay. So you're able to do all that. Okay.
Yeah, it's pretty crazy.
It's like one. Yeah. Yeah, that's a lot of versatility.
Because other companies are mostly either building the hardware or they building like applications for other platforms, and we are like only ones that are like insane enough to like manage it all with a pretty small team.
I'm a big fan of vertical integration, which is what we're talking about. Are there places where you could have done horizontal integration and still achieve the same level of success in terms of what you were building, or is it just easier to do it all in house? Like, what was the logic of doing vertical? I just naturally go towards vertical because then you control more of the variables. But I mean, there's also like maybe people are just really great at their thing and then you partner with them. What was the trade-off? What was the threshold that made you want to keep everything in house versus having parts that were built by other people, or just being a layer that would exist on other people's products?
Well, yeah. We are building everything in house, but we haven't started from scratch. So there were already some open source algorithms on top of which we could start building, and they hardware part, we also don't build from scratch. We don't build like camera sensors or something like that. We just assemble off-the-shelf components in a unique way, kind of.
Even that's pretty unique.
So
even just as the assemblage is pretty unique in terms of like most people. I don't know. For a long time listeners, you'll have heard other people talk about the way they do it, but like we're implying here and just state it. Most companies that you hear out there are just one layer of what you just stated. Most people are like, I'm going to build an application that exists in other things. I'm going to build a hardware which then other people can exist on or have this one feature. To do the whole gamut, there's many benefits for it. Downsides, maybe cost or whatever. So this is actually quite novel in terms of my experience. Like most people will choose, I'm going to build the hardware and then plug into an existing software that'll like make sense of the noise or the pictures, or they'll build the algorithm that'll exist into a platform. And then, but you're doing the whole thing, which is pretty cool. So I guess I'm trying to understand the what made you want to do all of it versus just a component of it.
Yeah. So basically, there weren't. So my former supervisor, Joe McInnes, when I studied cognitive science. So he is an expert in visual attention and AI, and like eye tracking is his favorite research instrument. And we were like working in the lab, and basically no, we didn't have any system that would actually like satisfy our needs. So like first we just wanted to like build a like a research tool that we could use ourselves, and it's required some hardware work, and I guess the all other layers they also like came naturally, since we kind of understand the hardware. We know what kind of algorithms would be the best to couple with this hardware. So it didn't make sense to like only assemble the hardware, but delegate the core algorithms to someone else. And then, since we also have neuroscience background and some experience with research, we also understood what kind of UX components would be the best for the research use cases.
Is it theoretically possible with your device to kind of, if you were looking at someone as they look at those eye charts, this is a bit of a jump just for people listening in, I just thought of it. If you were looking at one of those eye charts, could you detect their ability to see what they were seeing, like if they could see it well or not? With your, I feel like you probably could if you had like the eye chart, and then like if they were scrunching down to try and see the information versus being able to see it naturally, you might be able to guess it that way. But is it possible to like walk into a room, sit down, have your device looking at my eyes, and then look at a chart and then scan it up and down, and you'd be able to know what prescription I need to have glasses?
So would be I think not like the visual acuity, but it would be certainly possible to trace back like so there is a tool called opacity maps or shadow maps in eye tracking research, and basically it's a visualization of so of the area where you were looking at when you're like seeing a movie or something. So like all the regions of the screen would be like blacked out, and you would have like this kind of a radius which shows where how did you view this particular like image or video. So other people could kind of replay that from your perspective.
That's interesting. And then for you personally, is there an application or a use case, or is there research? Is there an aspect of what your product and service are going to be able to do that you're most excited to see happen in terms of what is like in terms of most likely it'll happen, or some things that you like are just kind of dreaming like, I'll be like, once it's built and it's out there, what you like, oh, if that were to happen, that'd be kind of wild.
Yeah. So we started with research because, first of all, we believe that there can't be any significant innovation without research, and basically since we knew the customer problem and the we had a pretty good initial idea of what would be the good product for the research use cases, but the downward layers of our system, which are like the hardware and the core algorithms, they are like generic. So they're just enable a collection of high quality iMoments data. So you can do a lot of other things to that as well. And so, Lowell, how many times a year do you go to a dentist to check up on your teeth health?
Like once a year. I don't know if I'm supposed to do it more than that.
Most people do that once or twice a year. While we are doing that for our teeth health, we're for some reason that I'm missing, we're not doing the same for like our brain health, which is like kind of our most important organ. So we're not doing that until something is not working properly. And if something is not working properly, in most cases, it's already too late to significantly improve the outcome.
Yeah.
So one of the use cases that I'm particularly excited about is like a brain screening tool to do like mass screening of healthy individuals for neurological or mental conditions. Because there is a large base of evidence that abnormalities in iMoments data can signal of brain-related disorders. So, for example, if you show like it's schizophrenia is like a psychiatric disorder, but still also applicable here. So if you show a schizophrenia patient and moving object like a tennis ball, for example, and you ask him to follow the path of the ball, there would, because of the like hallucinations and delusions that he experiences, there would be like gaps in this kind of path. While with the unaffected participants, you would see like almost a perfect kind of line following the ball when you like visualize the gaze data.
That's interesting. Would you know like the severity of the schizophrenia, or or would you just know like there's something like blanket umbrella? There's something schizophrenic going on. Like what level of granularity can you get?
Yeah, so unlike neurodegenerative disorders, for example, in usually most people get better over time when they have schizophrenia and not worse. But it's important to detect it early, because when people just have schizophrenia, there is a high risk of suicide.
Yeah.
But to answer your question, yes. So you can not only you can detect brain-related disorders, but you can also monitor. You can also objectively monitor either treatment effectiveness or the progression of the disorder over time.
So then the best way to get the benefit of your technology. So every year, I see a doctor, get the physical, blood drawn, stuff like that. There would almost be like a part of the family office or wherever I go where they just like have your technology and they run me through a bunch of tests real quick. It's like, hey, here's like just follow this ball or whatever, and they'd be able to get a sense of where I am mentally as well. That does involve like a CT scan, or like, well, I guess eventually you could go to CT scan if something significance being shown, but that'd be a natural process that exists in a regular checkout that people would get to make sure that they're healthy. And if something's off, like last year, my doctor was like, "Lowell, your cholesterol's starting to get high. Lose weight or you're taking a pill." And I was like, "Okay," but so versus like if you don't do those things, then you have a heart attack or something, and then you can die. So the idea here that I think many
in the Netherlands, if you go if you go to the GP, he will like prescribe you like paracetamol if you were like having a brain tumor or something. Like in any case, the paracetamol is the way to go.
What's a paracetamol?
Paracetamol?
Yeah, what's that?
It's like a antibiotic, I think.
An antibiotic?
Anabolic. Like the you feel less pain, kind of.
Okay, so it's like an anabolic steroid, like the type to like get rid of headaches. I'm used to drugs in America that sound like they could be marketed, which is something that the Americans allow, which the EU does not. So that might be a difference here, where yours are like probably more technically accurate.
Panadol, you know Panadol or Tylenol?
No, I never heard this. Yeah, it comes down to like messaging.
Basically, it's a painkiller.
Oh yeah.
But yeah, so I didn't know you have another brand in the US. Makes sense.
Yeah, well, America, you're allowed a component of pharma is spent on marketing. Where I think in the EU, where you're at, you're not allowed. If you make the drug, you're not allowed to market it directly to consumers like me. Where America, we're pretty chill about that, which is not good. Actually, I'm not a fan of that. But I think that might be the difference. They might, they might change the name of it to make it sound nicer. Versus, if only doctors were seeing it, then they'd probably be able to be more technical.
Yeah, I heard that in the US, like the healthcare system is like operates in the same kind of way as any other business, while in Europe it's more like it's more like centrally regulated.
Yeah, there are regulations, but America's weird. America's a weird place. I think that like the insurance companies get a lot of benefit from regulation. They also have things they need to worry about. I mean, it's in some ways it's getting better. I think at one point in time, insurance had lifetime caps. So if you're like 32 and you've had to take insulin your whole life and it's cost like $1.2 million total in their coverage, they'd kick you off the plan and you'd have to like get a new premium with a higher one with a higher whatever. It's like, I hate that shit. It's like you're in insurance, you just pay for things. I don't know. But America's a weird place. We're I feel like we're quite backwards in terms of how our insurance and healthcare is. Like in America, you can decide: are you going to pay this bill? Are you going to be homeless? Or are you going to die? There's so many people that won't go to make sure they're okay just because it'll cost too much, and they can't afford it. They can't afford the time off and all these other things. I think that's all pretty shitty.
Yeah,
and it makes me sad inside. Yeah. So, but anyways, ideally, I actually got sad just now. But for your product, in ideal scenario, you'd be a part of that healthcare checkup, making sure where you're at, how things are going, and then so that people can intervene early.
Yeah, that's the idea. Though, yeah, we still have to make our system more easy to use, so it can be directly used by either neurologists or even GPs or nurses.
Yeah. What steps remain to make it something that a nurse could do, just like run someone through as they're there?
Basically, a bit different approach to building the product. So currently we have kind of very open system, and that's because the researchers are more like technical folks, and they love to tinker with parameters and customize a lot of things for their own research. While doctors typically don't have much time on this, and if there is something that is if there's something for which they need to do more work, this would never be adopted by them. So you would never get into like clinics or hospitals. So for medical professionals, we are building more like a closed system where they can just like press a button and have press a button to start collecting the data, and then like basically after the 15 minutes, they would have like an interactive dashboard where they can explore the biomarker data to make a better informed decision.
Mm-hmm. That makes sense. Could you just have one standardized product that then allows customization, so you don't have to have like two different products for researchers and clinicians? Could you just have a standardized product that people can still customize to their interest after that? So then, I'm thinking from your point of view, just make it simple, so you don't have to have like multiple SKUs.
Yeah. So the hardware is the same, and the algorithms that make performance are the same. So they're just like different like user interfaces, and medical product also like requires ML classification layer to distinguish between neurotypical and neurodivergent populations. Yeah.
All right. So a part of the platform is also analyzing and understanding the data. It's not just, so you're also going to have some level of understanding, kind of like interpretation of what the data is, to help the clinician or researchers understand what they're seeing faster.
I think not for researchers, but for clinicians, yes. I think most researchers would prefer to come to the conclusions by themselves. But of course, if we can just output only the like raw statistics without educating doctors what's it about. So some level of interpretation is needed. Yeah.
Then in terms of time, how long do you think it'll be before you have something like that that'll affect clinicians versus researchers? It sounds like researchers would be an easier bar to hit because they're a little bit more open, and there's less of a bar in terms of making it usable and easier as clinicians would be.
So for the research purposes, our product is already on the market and used by research university labs across Europe and the United States. So for the medical product, we are looking for pilots with the hospitals and pharma companies as well. So basically, the path to market is longer because there is a regulatory pathway that we need to overcome. But we already make revenues from the research market, and we can reinvest them to complete the product for the medical professionals.
Is there a rough time horizon to get it that you'd expect for the medical professionals? Like, we're talking like a couple of years, a year, a decade? I don't know.
Yeah. So it will take us a year to certify it as a medical device.
That's not too bad. And, in the grand scheme of things, like sometimes it takes several years to get things into a certain stage.
Yeah, I mean, as compared to like invasive devices or something like that, or drugs, that's much faster path. Yeah.
Are you do you have the team you need? Do you have the funding you need? Is there anything missing just in terms of those components?
Yeah, so maybe to talk a bit about how the work is currently being structured in our team. My co-founder is and CTO, he's an expert in high performance computing and an ex-NVIDIA engineer. Then we have our engineering team that is building the hardware and building the core eye tracking algorithms. And then we have a neuroscience team that is looking for abnormalities in the eye movements data and searching for novel biomarkers and perform experiments and collect data. We have a hardware. We're like multinational company, so we have a hardware lab in Lausanne in Switzerland, where our devices are being assembled, and then we have like a neuroscience lab here in Utrecht. So actually, our Utrecht lab is located in a historical building, which is like an abandoned prison. So it was actually like functioning as a prison until 2014. And so the very room where from where I'm talking to you right now used to be a prison cell. So
I thought that was a weird window. There's a window on to his back right, and I thought that was a weird window this whole time. I was like, that's a weird looking window. I just didn't want to comment on it in case he lived in like a cellar or something. Okay, that makes sense.
Yeah. So yeah, our Utrecht lab has the code name the cell, and yeah, so yeah, that's a bit about our team composition. So we have computer scientists and electronics engineers and neuroscientists, and we even have one rocket scientist in our team. So yeah, we use a lot of multidisciplinary collaboration to get novel insights into the field. Being an eye tracking expert is not a requirement to join our team. Actually, yeah, I think. Yeah, at least half of our team didn't have any prior background in eye tracking. So kind of we're trying to also not be too much bounded by like the prior research and like dogmas of the field. So kind of new unconventional ideas could be born from taking ideas from other fields, or like cross merging different fields together.
And then is there, I think you're looking for a couple people to join, right? You're on the lookout for some, I think it's like C++ embedded systems person. I don't know. I think you're looking for someone to join your team.
Yeah. So we're looking for a dedicated hardware person. Yeah, and then yeah, for an embedded software engineer as well.
Sweet. Is there it's kind of, so is there actual AI in terms of like a ChatGPT type thing being developed, or is it more like machine learning and then understanding what is being seen in terms of the platform? Sometimes, like, people put like AI on things, but then is it actual artificial intelligence, or is it just like machine learning, understanding the computation of what it's seeing?
Yeah, I love that that question and how you frame it. The term AI is so overhyped, and most in most cases, then people say AI, then they mean machine learning. I completely agree with you. So for us, they're like, so we are currently using ML algorithms to improve the accuracy for improving like the core eye tracking algorithms themselves, and then we are planning to use ML for finding the abnormalities in the eye moments data.
Okay. What just talking about machine learning and AI on a high level, what do you think about ChatGPT and all this like stuff that's been coming out? I like ChatGPT. It's actually quite nice. It's like it's a fun thing.
What are you using it for?
I used to learn, actually. Yeah, like there are times where it's like, if I'm when you Google something like how to cook a fish, right? How good is that information? Versus if I put in ChatGPT, I say, imagine you're Gordon Ramsay, and you're teaching me how to cook a fish. Like, give me the steps and the links to do it. It gives me all the stuff, including the citations, and it's nice. Like, there's a little bit more of like I I have a sense of what I'm looking for, but then it's also like Gordon Ramsay saying the fish is fucking raw, which is kind of fun too. There's a little bit of like serendipity. It's like if I want to like learn, I'm like, oh, I'm kind of curious about this subject. Can you like break down the segments that I would need to learn, and then I can look through those different segments. Like it's really cool in that way. Like instead of like reading like a Wikipedia article and like spending like half an afternoon to understand a new field, I can have like the gist of a new field to then spend like an hour and understand it much quicker. I use it to learn much more efficiently is my main use case. What about you?
Yeah, awesome. I use it to write copies and edit emails mostly, I would say.
Mm.
But in terms of like what does it mean for society, and like we're currently experiencing some tremendous shift. I would say that I'm somewhere in between, like perhaps more skeptical folks, as like Jan de Koon, for example, who say that that's like large language models are like nowhere near the like AGI or like artificial general intelligence, and like the Microsoft folks who like already announced that it's that it is the AGI. So, but I'm slowly updating my views to being like less skeptical, because I was skeptical before even that thing happened, and now I need to update my views more to the side of things where like where it starts to change how the society operates, despite that it's not an artificial general intelligence yet.
It seems like it's a really I think one thing that's doing, which I think is kind of funny, is like it's giving Bing like an actual like someone actually want to use Bing now, where it used to just like if I was looking for something, like I was Googling something, it's Googling. I'm Googling it or giggling it, depending on my mood. But like Bing, you can have a conversation with the dialogue, so it makes Bing pretty usable. Like Microsoft is doing a lot of stuff like that, where like there's GitHub Copilot, and I've been experimenting with that. I'm like somewhat disappointed. It saves me like, I don't know, like a couple of minutes to like write out the code. But like I look forward to the type where it's like integrated in, where I can have like a conversation with my code at the same time. That's will be kind of fun. But like I think it's neat where like Bing is like this thing that most people would never use, and now because of that conversational ability to look things up and Google and have like some type of filter to it, I think that's pretty cool. That's more of like a joke though. I think that it's just funny that Bing has like a resurgence with this technology. There's like Google has competition now.
Yeah. I haven't tried I haven't tried Bing yet, to be honest.
Oh, it's fun to play with. I still would like it's fun to use, but the combination of ChatGPT and Google is fine. It's just an extra tab in my life, and then usually ChatGPT you can have like links clicking away. Related to ChatGPT and your own technology, what do you think about the fact that like the data to generate the models, like yours or others, is being generated by people, and yet maybe it'll like supplant people in some way, like take their jobs or whatever. Do people have any right to privacy or any ownership of that data? Like, what do you think about the fact that like the training data for ChatGPT, for instance, is like the internet and stuff, which is people, and yet the people don't get like a percentage.
Yeah, I think that first OpenAI should be named like ClosedAI, definitely. So yeah,
or was OpenAI.
Yeah, maybe it was like the OpenAI on the day one, but when they become a for-profit company, it's I think not really ethical to if you're like train models on the whole internet, maybe you should make them open source.
Yeah. I think that's there was either an interview that Elon Musk did or someone was talking about this where that's what pissed Elon Musk off, is that when he came in and gave the like one of the initial 100 million, he wanted things to be open, but then they kept closing, and it was like, well, that's not what this is about. And then he sold his shares. That's like rumor mill. I don't know to the extent that's real.
I think that's exactly what happened. Yeah, because kind of so, Sam Altman had a different vision, more business oriented guy.
Yeah, I think before OpenAI, he did Y Combinator.
Yeah,
like the VC side of things. So should be a fun time. Anyone out there looking to use these tools and use them, comment below and let us know how you use them, because it's an evolving field. I think that's one of the coolest things. I haven't checked out ChatGPT 4 though, because I'm not paying for that. I'm cheap. I just use the free, thing. Though I have been wondering how, if you use their API in conjunction with something like Twitter, if you could really fine tune the news that you get to be what you want it to be, and then translate what's happening into a language that you're comfortable with. I've been thinking about calling it like your news, where you give you give it the parameters of your life, like I'm a single mother who's a teacher at this one school in this one county, and it tells you like all the legislation or news that's affecting you in your life, and then it goes all the way up to the things that you care about. I don't know. It's something I think about, because there's a lot of stuff I learn about news, and some of the news is like, why would I give a shit about this? I don't care about some. No offense to people who like sports, I just don't care about sports. But I get a lot of like sports news.
In your feed.
Yeah, for Twitter, it's like I keep ignoring it, and it keeps coming back. Twitter's great for news. I follow a lot of scientists. Hey, where do you go to learn when you're learning something new? When you're looking at language models or anything like that, where do you go to learn? Or languages in general? That's one of the things we're going to talk about. How do you go to? What do you do? What do you do to learn new things?
Yeah, I think so one of the places to get like an initial idea to like for more exploration versus exploitation would be YouTube videos, I think. So they're cool cool YouTube vloggers who talk about for machine learning. For example, there is Yannick Kilcher. So
I have to look him up.
the guy who is always with the sunglasses.
No, I don't know him, so I'm gonna look him up after this. I always like learning new things.
Yeah, so
I can't picture him.
So he does like great reviews on the recent ML papers. So
that's pretty
cool. I'd recommend that. Where else do I find out about stuff?
YouTube is pretty good for serendipity. It kind of like the algo is pretty keyed in to get you to stay there and be happy.
Yeah. So about learning languages also. I follow a bunch of this YouTube polyglots kind of people, and I'm fascinated by this, and I would also love to get to a conversational level on multiple languages.
What all languages do you know currently other than English?
I know Russian, then a bit of Dutch, but it's like completely useless because everyone in the Netherlands speaks really good English. Like literally everyone.
Yeah, I hear they're tall too. People are like giants.
Males are so in terms of males, the Netherlands is the tallest country, and I think for women they're like the tallest females are in the Latvia, or I think in Latvia for some reason. I don't know why. Yeah,
we gotta find a way to get Latvian women to Netherlands men, and then just like we'll make a giant. That doesn't work. Let's not do that. But there's don't look into what that would look like. But all right, so those are some of the places you check out. What advice would you give to aspiring entrepreneurs or researchers? Alternatively, if there's maybe that's too specific or too broad, people who are 25 to 35 who are in their first profession but are looking around and are thinking like, I don't know if I want this. Like, what advice would you give to people who are first getting out there or who are looking to build their own thing?
If they're like, do they already have? I think there's we need to specify if they already have a concept of what they want to build, or they're looking for, or they're looking for an idea, or if they already have an idea and they want to find out if that is the thing they want to pursue.
Yeah, that's a good delineation. I'm going to take a stab and let's go with they have an idea and they want to know what to do with it. And if people are in a different camp, comment below and I'll ask the next person about how to help you with that. But I think I don't know, is that the hardest part? I don't know what's the hardest part, to find the thing you want to work on, to build the thing you want to work on, or to translate what you want to work on. So whichever one you feel like you have the best answer to, I guess it's a really good question. I don't know how it would break down in terms of the people listening in. I think you'd if you answered each of those, you'd probably hit someone. You'd probably hit someone, but then we have time.
Yeah. So I think for entrepreneurs, at least, there exists pretty. The path is easy to understand if the idea is worth pursuing. Basically, So as basically, they should test if there is enough people that want this thing that in order for it to be a commercially viable enterprise. And there are ways to do that. Start with customer interviews, customer development. There is a nice book called Mom's Test. If you want to dig deeper into that. Then try to build the first prototype as fast as you can with sticks and bricks and anything you can find. So it's so it kind of resembles at least a tiny way the thing you want to develop, and have people from your target audience to get enhanced to the people from your target audience. So of course, for people building web tools and like hardware things, this is it's completely different paths. Like for people building hardware probably they couldn't just put a landing on the website in a week and get the traffic to this website and validate their idea in a couple of weeks. So for I don't know if there is a shortcut. We had to build our product for years before we could show it to anyone.
Mm-hmm. I think my grandfather had a saying where if you have a short path in front of you versus like if you're at a fork in the road and there's a long path but there's a short path, you should always pick the long path because you'll most likely have to take it anyway. So why not plan for it and then you'll be able to account for the different variables versus people who take shortcuts. You end up like going over that land quite often, so you end up doing more work, more energy. Then you just kind of get irritated.
So it's kind of anti-growth hacking, I think.
Yeah, yeah. I'm more. I generally think like pick the thing that's more frustrating, or like it's kind of like eat the frog method. You know, do like the worst thing first, and then you can gain strength for it. Versus if you do the easy stuff first, like it's burning your mental energy to make decisions. Like you only have so much mental energy in a day. But what are some advice that you've gotten that is like just terrible? Like, you know, over your years as an entrepreneur, what's like terrible advice? And so that, you know, people listening can, you know, avoid it.
Great question. I need to chew on it for a bit. Something that you mentioned, it's this is really interesting. I mean, it's always also been a dilemma for me if I should learn things that are naturally hard for me, or if I should focus on things that come more naturally to me and developing in those areas. I think like, but also if so the frog, it means like that you do the most unpleasant things first.
Yeah. So like when you get up in the morning, some people will take like easy wins where it's like, oh, I'm going to write an email or whatever. What is easy for you? Eating the frog is like, if you know you have a big, if you're like coding a block of thing and it's been like pissing you off for 3 days because you can't figure it out. Like you start there, even though you know it sucks. Because then if you're through that, if you can get through that, then the rest of the easy stuff is easier. So you just pick the most frustrating, hard, difficult thing to do that'll move the needle forward in terms of your vision for yourself or your company first.
Okay, so I think I'm following this approach, but with some exceptions. So I usually try to do the most maybe not the difficult one, the most like important one, I guess. The thing that I allocate the most value to. Yeah. It is not necessarily the most difficult one, but usually there is there is a correlation. But sometimes I would switch to something that I could do fast, that I could implement fast. So I can get the kind of dopamine release for the completeness of some task that would give me more energy to get back to the harder task.
Yeah. I can see that being like kind of like a wave through your day. Like you do the hard stuff, it drains you. So then you do some of these easy wins that then it gives you the strength to do it again. So you can, versus just like gritting your teeth and forcing it through. Anyone who's ever been running, if you try to run as hard as you can and grit your teeth and do it the most extreme way possible, you'll actually run less efficiently and effectively, and you'll be slow. Like you won't actually run your fastest doing that way. So it sounds like kind of like that type of method where you're kind of like you're maximizing your hard, difficult with your lows to get like a baseline of productivity. If that makes sense. I don't know. That's how I summarize it, but I think people would understand you saying it as well.
No, I think you put it really well.
Yeah. So then, what books would you recommend people check out?
Oh yeah. So I'm a pretty old school innovator, so I never really adopted ebooks. So I read like physical books.
Yeah.
Or like tangible ones. So yeah, I brought some of them with me. So and we already so since we already touched a bit on it before the recorded part, I guess. So when did Facebook rebrand to Meta? Like 1.5 years ago, something?
Yeah, something like that.
Yeah.
I think it's dumb, but
So
yeah, they're annoying.
I was trying to understand like where did this hype about metaverse came from? Does it like because I haven't heard about any significant improvement in the VR technology over this time. So I was trying to kind of get to the origin of this hype. And yeah, also like there are some fundamental I believe that XR technology has a lot of potential. However, there are some fundamental limitations that have to be overcome in order for the widespread adoption of this technology. So like this metaverse thing, apparently it presumes that we would like spend half of our lives in VR or something. However, currently, like after the 20 minutes of like wearing a VR helmet, like people get dizzy, and yeah, they so this phenomenon is called VR sickness, and apparently the theory behind why this is happening is because the sampling frequencies of the images and the audio are not in perfect sync with our sensor with our sensor modalities. And yeah, so that's why after 20 or like 30 minutes in VR, people get dizzy. And yeah, not much people. Some people talking about it in academia, but almost no one talks about it in the industry. I know only one person, I think, who is openly talking about it. Is Jack Macaulay, who is one of the co-founders of Oculus and their lead engineer.
Yeah, he's in the defense department, right? He works on defense stuff now.
I think so. Yeah, I know he's in the board of.
Is this a book? Yeah, but is this a book?
So yeah, so I wanted to get to the origin of how it started, and the term metaverse was first coined by Neil Stephenson at
Snow Crash.
Snow Crash, yeah.
I have Snow Crash right there.
Awesome.
You actually can see it kind of very small.
So yeah, absolutely fascinating book. So I'm a huge fan of like sci-fi and like cyberpunk in particular. So like my favorite authors are Stanislav Lem and William Gibson. I recommend, I read almost all their books, and I can totally recommend them. So I wasn't familiar with the Neil Stephenson work before, and yeah, I was really impressed. I mean, not only the virtual world that he envisioned was interesting, but maybe even the like real world was more interesting than the virtual world in this book. Because he used, I think one of the technique he uses is reducto ad absurdum. So like take something that already exists and make it like maximize its absurdity, kind of. So like, for example, even like the how like the Italian mafia and police and like military all became like for-profit corporations, kind of, and like how there can be like so the geographic borders kind of the countries were like kind of inverted, and there could be like an exclave of any kind of country in any kind of different country, something like that. Yeah, I think it's very cool, but also like it's a mix of everything, like with the like Mesopotamian culture and Christianity, myths, and like linguistics and stuff. Pretty much everything. So yeah, very fascinating book.
Sweet, and that'll be in the show notes as well. I think that is unfortunately all the time we have. I know we had other things we wanted to discuss today, but we got to stick to a schedule so that you're able to work for the rest of the day. So I want to thank everybody for tuning in this whole time. Subscribe, comment, let us know what you think, and I want to thank you for coming on the show and taking time to talk about Purple Gaze, everything you're working on, and getting people excited for the future.
Awesome. Thank you for having me.